Hello and welcome back to some more weekly exam problems. Back in the maths storeroom today. This time we're going through the week 3 exam problems, so there's just 2 to cover in this one. So the very first question here, we've been given a graph. We've been told that the graph has this form here, and we're required to solve for A and B to figure out what that is. So every time you have a question like this, whether the graph be polynomial, whether it be linear, whatever it might be, let's just start by defining the function in terms of roughly what we're trying to look for. So in this question, we're trying to find a function that looks like this. So y equals tan of ax plus b. And we have been given two unknowns. And the general idea is if we have two pieces of information, we need to we can use those to find two unknowns. So given two unknown letters, like in this case A and B, we can use these two coordinates that we've been given on this graph. So this one and this one, we're going to use them to solve for A and B by creating a system of simultaneous equations. That's the idea. So let's put that into practice. So first up, I'm going to just take this formula and I'm going to substitute in -1. And I know based on this data point, when x is equal to -1, y is equal to -1 as well. So I know that if I put in x as -1 in this formula, so if I put in, instead of x, I put -1, this will become a times -1, which will be -a plus b. Okay. And similarly, if I put in 1 into this formula, I should get an output of √3. So let's have a look at what that looks like. So the y value is going to be √3, and the x value is going to be 1. So if I replace x with 1 here, I just get a times 1, which is a, plus b, and we get this little system over here. So let me call this 1 and let me call this 2, and I'm just going to have a look at 1 first up. So I've got here tan of -a plus b is equal to -1. So when does this occur? So the secret is we're going to be considering our two special triangles that we're going to use for essentially every single question involving trigonometry. The first one being, we have a triangle that looks like this. So we're going to have side lengths 2, 1, and √3. This over here is pi on 3. This one up here is pi on 6 in terms of the angles. And then we have another right triangle, which is like a square that's been cut in half. We have 1, 1, √2, and we have an angle of pi on 4 radians in here. And that's also pi on 4 up there. So these two are the same. So let us consider, of these two triangles, which one do you think is going to give us a tan of 1, say, for example? So tan is equal to 1. So remember, tan is opposite over adjacent. So it would be 1 divided by 1. So therefore, an angle of pi on 4, tan of pi on 4 would be equal to 1. So therefore, it would be 1. It would be pi on 4 in the first quadrant. So -a plus b. If this said +1, then it would be pi on 4. But it does not say +1. It says -1. So when is tan negative? Well, if we think about it, tan is negative in the second and the fourth quadrants. So specifically, we're looking at one rotation. So if we think about it, when we go around a unit circle, so if we go in this direction, we're traveling in a positive direction. If we travel in this direction, we're going in a negative direction. If we look at this graph, this is showing us the very first time that tan is equal to -1. So we're between this first rotation over here. So that tells us that we must be in quadrant 4, because if we were in quadrant 2, for example, we would have gotten a negative solution and then gotten another negative solution. So that would be if this graph continued over here and we had like another curve over here. The second one would be in the second quadrant, but this first one will just be in that quadrant there. So long story short, we get an answer of -pi on 4. Okay, so that was equation 1. Now let's consider equation 2. So equation 2 is tan of a plus b is equal to √3. This time we're going to look at this triangle over here. Tan is opposite over adjacent. So in order for us to get √3 as the answer, we should be looking at this angle here, pi on 3. Because if you look at pi on 3, opposite over adjacent is √3 over 1. So therefore, we're going to find that a plus b must be equal to pi on 3. And again, we're not going to consider the other the other quadrants where tan is positive. So remember, tan is going to be positive here and here. We're only going to consider the first time because we've only got the first, like we're looking at the, we've got the y-axis here, so we can see this is the very first time that tan is equal to 1. If the graph continued over here somewhere, then we'd have another point, 1 something. I don't know what the other coordinate would be. We don't know enough information yet, but that's the idea. Okay, so we've created our system of simultaneous equations. Let me write these two equations as a system so we can see what we're trying to solve. We're trying to solve a plus b is equal to negative pi on 4. So that was from here. And then we have a plus b is equal to pi on 3. This is our system of equations. We're trying to solve this for a and b. You could just type that into your calculator if this was tech active, but just to remind you how you could solve this by hand, we can use substitution, we can use elimination, whatever you like. Let's just use substitution, for example. So we've got negative a plus b is equal to negative pi on 4. I'm going to add a to both sides. So we get b is equal to a minus pi on 4. Okay, I'm going to take this, I'm going to sub it into a plus b is equal to pi on 4. So pi on 3 was the second equation. So sub it into the second equation. We're going to get out, replace b in this equation with what we've just found. So a plus a minus pi on 4 is equal to pi on 3. So I've just substituted in this value here. Instead of writing b, I've replaced it with what we know b to be equal to in terms of a, which was this value here. So I have effectively combined the two equations. So now we can simplify this just a little bit. We collect these terms. We have 2a minus 4 on 3 is equal to pi on 3. And we're going to have to keep going with this. So let us just move up here so there's a bit more space to work with. What I can next do is add pi on 4 to both sides. So we end up with pi on 3 plus pi on 4. Okay, and now we have equivalent, well, we have two fractions with different denominators. We need to write them with the same denominator. So the way we do that is we multiply them by the other one over itself. So for example, we could multiply this by 4 over 4, multiply this by 3 over 3, and that way both of them will have the same denominator, and that denominator will be 4 times 3, which is 12. So we're going to have 12 down the bottom, we'll have 4 pi up the top here. This is 3 pi on 12. Now we can just add these two things. So if we've got fraction addition, so we just add the two numerators, we keep the denominators the same. We get 7 pi over 12 is equal to 2a. And therefore, if we just divide both sides by 2 to get rid of the 2 over here, we find that a is equal to 7 pi over 24. Now we're going to take that value and we're going to sub it into our equation that we found here for b, or we could substitute it into either one of these equations, it doesn't matter. So we substituted into b is equal to a minus pi on 4. That's the one that we found over here when we rearranged the first equation. That tells us that b is equal to 7 pi on 24, and I want to write pi on 4 as something over 24. So how do I turn 4 into 24? So I'll need to multiply that by 6, which means I need to times the top number by 6 as well. So that turns out that that fraction could be written as 6 pi over 24. And now we can see that 7 pi minus 6 pi is equal to pi, just 1 pi. So this gives us pi over 24 as our final answer. So we find here that b is equal to pi over 24, and a is equal to 7 pi over 24. And those are our two answers. And those are your 2 marks. So you get 1 mark for each of those correct responses, and 1 mark for successfully setting up this little system of simultaneous equations over here. If this was 3 marks, it's probably going to be 4 marks. You'd need to set up the system of equations, probably get these results at the start, so that's probably worth 1 mark. 1 mark for creating the simultaneous equations, and then the 2 marks for solving them if it was 4 marks. Okay, moving on. So we'll go down and have a look at this question here. So this one requires us to solve this function, and we're trying to obtain the general solution for this function. So working through this step by step, question A requires us to state the range of G. So looking at this, the range of G, so when we're talking about range, we're talking about Y values, the outputs. So what could this value take on? The way I would approach this is first just look at the sine part here. So something that we know about sine and cos for that matter is that they are at most 1 and they are at least -1. This comes from the fact that sine is just a point moving around the unit circle. Specifically, it's the y coordinate. And that y coordinate can be at most 1 and at least -1 because this is a circle of radius 1. So we can't be any further than 1 away from the center. So we've got this as our little property of sine, and we can see here that what we actually have here is 2 sine of 2x. So what can we say about this? Well, we know that that's going to be at most 1 times 2, which is 2, and at least 2 times -1, which makes -2. So therefore, we find that the range of this function is going to be y will be at least -2 or at most +2. So that's the answer to part A there. Okay, part B, we're required to calculate the period. Now, whenever we're trying to find the period of a function that looks like, say, for example, y equals, let's write it as y equals sine a sine of n of x minus h plus k, or y equals a of cosine of nx minus h plus k, where a is the dilation factor, and then n is what affects the period. So this is going to be the dilation factor away from the x-axis, and this is going to be the dilation factor away from the y-axis. This is going to be the horizontal translation to the side, and this is the k, which is the vertical translation. Whenever we have something written in this form, the period will be equal to 2 pi divided by the coefficient of x, which is what I've written as n here in this formula. So 2 pi over n, and putting it into this case here, the n value, the coefficient of x here is just 2, so the period is going to be 2 pi divided by 2, which is equal to pi. Okay, so now we're up to part C, which is the challenging part of this question. So we have to start by writing out what we're trying to solve. So we want to solve 2 times sine of 2x equals root 3 for x is an element of R. What that's saying is we want to solve this for all possible solutions. So how do we go and do that? So the first thing that we're going to do whenever we're solving this type of problem is we want to solve, so step 1, I'll write it out, solve for solutions in first rotation around the unit circle. So that is to say, like the angle theta is going to be at least 0 and at most 2 pi. And we can just ignore this 2x, just consider that theta, and then let's see what we can find. So the way this works is, first thing you're going to do is simply just rearrange this, make the sine part the subject. So let me go ahead and do that. We can simply just divide both sides by 2. So that gives us sine 2x is equal to root 3 on 2. Okay, so that's pretty straightforward. Hopefully everyone can get that. Next thing we might want to look at is this property over here. We're interested in sine. I see a root 3. I see a 2. My mind immediately goes to this right triangle, the one that has the root 3 and the 2 in it. So the side length here is 1, and this angle here is pi on 3. We're interested in sine, so that is opposite over hypotenuse. Yes, so it is going to be pi on 3. Okay, so that tells us that 2x could be equal to pi on 3. What else could it be equal to? Well, if we consider our unit circle, and maybe we'll chuck this at the center of that unit circle. Chuck this at the center of that unit circle there. When would we get this same y value? So remember, the y value is the y is the sine value, sorry. So the y value of a point traveling around the unit circle is sine of that particular angle that is made with respect to the horizontal over here. So when do we get that same y value? Well, the same y value will occur when we're at a point that is symmetrical to that point on the other side of the circle. See, it's the same y value. So that will occur when we have pi minus pi on 3. So we can see we'll travel around like that, pi, and then we go back pi on 3. We can also remember this using, cast. So for all stations to center, we see that sine is positive in the first quadrant and in the second quadrant. So therefore, we also have a second solution of pi minus pi on 3, which could be written as 2 as 2 pi on 3. So those are our two possible solutions in the first quadrant. Next, we can try and generalize this. So when are we in the first quadrant? So in the first quadrant, when we are an even number of pi's, so that's full rotation. So for example, it could be, we start here, we go around once, 2 pi plus pi on 3, we're back here, or 4 pi plus pi on 3, whatever. So it needs to be an even number of pi's, so 2n times pi plus pi on 3, or we could be an odd number of pi's minus pi on 3. That puts us over here. So that would be, the way we write an odd number, by the way, is 2n plus 1. So for example, 3 is 2 plus 1, 5 is 2 times 2 plus 1, pi minus pi on 3. Okay. So that is where n is an integer. So we say n is an element of z, z at the integers. So it could be 1, 2, 3, 4, 5, it could be -6, whatever it might be. Okay, so this is our answer. Can we simplify this any further? So let's have a think about this. First up, maybe we can divide both sides, because this is for 2x. We could possibly divide both sides by 2. That's going to get us a formula for x, which is actually what we're trying to solve. So if we divide both sides by 2 here, let's see, this will just become n pi. So yeah, we can just leave that as n pi. This divided by 2 will be pi on 6. Meanwhile, over here, we're going to get, it's going to be a little bit messier. We're going to have 2n plus 1 pi over 2 minus pi on 6. Okay, so what can we do with this? Can we simplify this any further? This one's looking good. I reckon we can probably simplify this solution a little bit further over here, though. So first thing we might consider doing is writing this as one fraction addition. So we want to make the two denominators the same. So we can times this by 3 over 3. That'll make the denominator over there 6. And then we end up with 6 over, so this becomes 3 times 2n. So that becomes 6n, and then we've also got to multiply by the pi over here. And then we have 3 times 1 times pi, so that just becomes 3 pi. And then we also have this minus pi over 6 part over here. We can then, because we have two fractions with the same denominator, we can write this as one giant fraction. And if we do that, we're going to get 6n pi, and then we'll have plus 3 pi minus pi, which gives us plus 2 pi. Okay, that's looking good. All right, now can we simplify this any further? Well, we could split this fraction again. I'm seeing a 6 here and a 6 here. So maybe what we can do is we can write this as 6n pi over 6 plus 2 pi over 6. The reason we do this, this is allowed because, you know, they both have the same denominator, just like we can add them by bringing them both on the same fraction, then adding the numerators, we can also split them in the exact same way. This then allows us to cancel out those 6's. Watch us cancel them out. 6 cancels out with 6. And over here, we have 1 divided by 6, so that gives us 1 over 3 when we cancel out a factor of 2. So that gives us a final answer of n pi plus pi on 3. And in other words, our two solutions are therefore x is equal to n pi plus pi on 6 and n pi plus pi on 3, where n is an integer. And if you typed this into your CAS calculator, that is exactly what it would tell you. So it will tell you that when we solve this function, 2 sine 2x equals root 3 for x, it's going to be equal to pi times some constant n plus pi on 3, so that's the second solution, or pi times some constant plus pi on 3. Okay, and those are your two solutions. If you want to think about a marking scheme for this question, I'd say these two first questions probably only going to give you 1 mark each. Yep, that's what it says here. And then it says 3 marks for that last question. So I'd obviously be looking at the correct answer here. 1 mark would be obtained for probably getting these two answers in that first rotation. So just getting those two answers and then doing this algebra here will give you the 3rd mark. So it's a little bit messy, but hopefully that gives you an idea of how to solve these questions. If you have any concerns about this or you're not clear about anything that I've just explained, please let me know, and I'll see you guys in the next video. Have a good one.